Welcome at Chhatrapati Sambhaji Raje Global School and Junior College, Ambazogai for online classes.
Hello students, this is our second video on class 9 chapter Force and Laws of Motion. In that session, we are going to learn about balance force and imbalance force. So before that, take one question, what does force do? In the last video, we learned about that question, what does force do? So what does force do? So if we apply the force on an object, object starts moving. So we take one example, carrom board, we strike the coin start moving. Or due to the frictional force, suppose that is a striker, if we strike the striker get moving, and due to the frictional force, that stop after covering some distance. Means applying force is needed for movement, accelerating that coin, and frictional force is needed for stopping that coin. Means force required to move the object, force is needed to speed up the object, and force is also needed to stop the object, slow down the object. So these are the main causes of force. So force are needed to speed up the object and force are needed to slow down the object. It means simply that force do the acceleration of an object. So it speed up, then that body accelerate, then it is stop, then body again accelerate. Acceleration means change of velocity. Change of velocity with respect to time. That velocity here, speed up means initial velocity is 0, and after pushing the that striker, it moves fast. So velocity of that coin increases suddenly. So that is the change in velocity. So that coin accelerate here, and in this case, the initial velocity of that coin, the coin is moving, and after application of frictional force, that coin will be stopped. So here also the acceleration is done. That coin is also accelerate here from some velocity to 0 velocity. So coin is also accelerate here. So what does force do? Force do the acceleration in object. Force do the acceleration in object. So we take some more examples. Let's go towards balance and unbalanced forces. So here some diagrams are there. So here two students, two persons, two boys. Name of first boy is A and second person is B. Name of first person is A and second person is B. That is a rope, and these two boys play a tug of war. So that is the rope. With the help of rope, these two boys want to play the tug of war. So here, both the boys apply the same force. Both the boys A apply the force in that direction, like this. A applies force in towards A, means in that direction, and B applies the force in that way. So these forces are equal. These forces are equal in magnitude. These forces are equal, but direction of both the forces is opposite. That direction of B's force is right towards right, and the direction of the A force is towards left. Here, both the forces cancel out the effect. Cancel out the effect of both the forces on that rope, and that rope doesn't move. That rope does not accelerate because of equal forces, and these forces act in opposite direction. So that's why that rope does not move anywhere. that rope does not move anywhere. That rope does not accelerate. So we learn about what does force do. Here in the last video we see that the force does the acceleration in object. So here we apply the forces, two forces equal in magnitude, and here is no any acceleration, because this happened because these two forces are equal and opposite in direction. Both forces are opposite in direction. दोनों फोर्स अलग अलग डायरेक्शन में अप्लाई है, मतलब अपोजिट डायरेक्शन में अप्लाई हुए हैं. That's why that rope does not move. We take another example. Suppose that a boy pull that box. That boy pull that box. So that boy applies the force in that direction, left towards left, but that box does not move. Suppose that box does not move, means that box, on that box there is one another force applied by the ground. That force is called the frictional force. Because of that, that box does not move. So that boy applies the force towards them, but that friction, that floor also applies the force in opposite direction. That is the frictional force, and the equal force in opposite direction. So that's why that box does not move. That boy applies a small force, then frictional also applies equal and opposite force on that box. That's why that box does not move. So here these two forces cancel out each other. That frictional force and that application of force, that force cancel out the effect of both the forces. So that's why that box does not move. So such forces we call them as a balance forces. We call them as a balance forces. That is most important. What are the balance forces? These are the balance forces. Boys A apply the force in that direction, boys B apply the force in that direction. So these forces are equal and opposite in direction. That's why the object does not move, does not accelerate. So these forces are called balance forces. These forces are called balance forces. So whenever we apply equal and opposite force, whenever we apply equal and opposite forces on any object, that object does not move, then these forces are balance forces. Whenever we apply two equal forces in opposite direction, then that body, that object does not move. So these forces are balance forces. Understood? These are the balance forces. This is all about the balance forces. So we take some more about these examples. For example, same boy A applies the more force on B. Boys A apply the more force than force applied by B. Means that boy applies more force. That boy applied more force than B. So what will be happen here? So here that rope accelerate. That boy is also accelerate towards A. Means that rope is moving like this. Rope is moving like this. That boy is also moving like this. Because of that applied force is greater than the applied force by B. So such forces is called unbalanced force. That force is called unbalanced. unbalanced force. Here in that example, we apply the more force on that box, then box get accelerated. That box get movement in that direction. So because of application of more force on that box, so that is the frictional force. Okay, it is applied in the opposite direction, but the value of that force is less than applied force. So that's why that box moves towards that person. So that force is called unbalanced force. And that unbalanced force in physics we call this as a net force. Net force. That is a very important net force. There is no net force. Here is a net force. Net force accelerate the object, means unbalanced force accelerate the object. Objects getting acceleration, it moves in some direction. And balanced force does not move the objects. So no net force does not accelerate the object, and that force is called balanced force. Net force accelerate the object, and that net force is called unbalanced force. So here is the second question. What is needed for acceleration? What is needed for acceleration? There is a net force. Net force is needed for acceleration. Here we apply the net force, it accelerates the rope. Here we apply the net force here, it accelerates the box in that direction. So net force is required to accelerate, required for accelerate. What is the answer? Net force or unbalanced force. This understood? So this is about balance and unbalanced force. So we take one more example. Here, suppose I want to ride a bicycle. Here I ride the bicycle. If I apply the force on pedal, then that bicycle start moving in that direction. If we stop the paddling, so cycle becomes slow down. Because of what? Because of application of frictional force in opposite direction. So where is the frictional force? Frictional force between that object surface and the ground surface. The surface of that tire and the surface of that ground. So in that portion, frictional force act. So if stop the paddling, then due to the frictional force, the speed of that bicycle decreases. That bicycle slowing down and finally stop. We again move the cycle, then we again paddling the bicycle, then it start moving. Means here the bicycle accelerate if we apply the force. It accelerate, it speed up. And if you stop applying the force, then it slow down. So that is the best examples. If next point is that here the bicycle has a uniform velocity. Then here which force act on that cycle? If the cycle moves fast, then unbalanced force applied on that cycle. If you paddling, we apply the force on that cycle, force on that bicycle, and that force is called the net force. And due to that net force, that cycle is accelerate. That cycle is speed up. If we stop the paddling and that frictional force is acting on that cycle, means that frictional force balances that applied force, and that cycle slow down, and finally it will be stopped. So that these two forces are the unbalanced forces, balanced forces. So if any object moves in a uniform speed, there is no any acceleration. If we apply the force on any object, suppose we apply the force on bicycle and it moves in a uniform speed, then that frictional force is also equal and opposite force on application of force on that body, and there is no any acceleration. Why? That cycle is moving continuously with constant speed, but there is no any acceleration. Acceleration means what? Change of rate of velocity. Rate of change of velocity means velocity एकदम से बढ़नी चाहिए नहीं तो कम होनी चाहिए. That is acceleration. But the object moves in a constant speed, so there is no any acceleration. That's why these forces are balanced forces. Here we apply the constant force, some F1 suppose. We apply the F1 on paddling, and the frictional force is acting similarly. Frictional force is acting on that bicycle with equal amount. Suppose F1, and that bicycle continuously moving with constant speed. So these two forces are equal forces, and here these two forces are balanced forces. Suppose, for example, if I push that chair continuously with constant speed, so there is no any acceleration because of the application force on that object cancel out the frictional force. Suppose I pull that chair and it goes continuously with constant speed, so there is no any acceleration. So that natural tendency of object is what? It continuously moving. Natural tendency of the object is in motion, stay in motion. In the last video we learned about that. If the object in motion, Galileo says that if object in motion, stay in motion. अगर ये चेयर मोशन में है, इस पे अगर मैं कोई फोर्स अप्लाई करता हूं तो उसका वो इक्वल एंड अपोजिट फोर्स फ्रिक्शन अप्लाई होता है. So here we apply a constant force on that bicycle, equal and opposite force acting on frictional force, equal and opposite frictional force acting on that cycle. So these two forces are balanced forces. यहाँ पे साइकिल तो मूव हो रही है लेकिन कांस्टेंट स्पीड में. अगर कोई चीज कांस्टेंट स्पीड में मूव हो रही है तो उस पे फोर्स अप्लाई करने की जरूरत नहीं है और उसको अपोज भी करने की जरूरत नहीं है. यहाँ पे अगर ये साइकिल कांस्टेंट स्पीड से जा रही है और मैं इस साइकिल पे कुछ फोर्स मैं अप्लाई करूं, इक्वल फोर्स, और उसका इक्वल एंड अपोजिट फोर्स फ्रिक्शनल उस पे एक्ट होने वाला है, तो ये दो फोर्स जो होते हैं वो बैलेंस फोर्सेस होते हैं. Here that a boy acts a net force on that rope, means that net force, that force is greater than that force. So here that is unbalanced force. Here that boy applied the net force, means greater force than the frictional force, then that is unbalanced force, that is a net force. But if we apply both the equal forces on that same body, then these forces are balanced forces. Here we apply F1 and frictional forces is also F1. These are the balanced forces. If one body, suppose one body continuously in motion, suppose that body continuously in motion, if we apply some force on that body and frictional opposite and equal force is applied by the friction, so these two forces are balanced forces. चाहे वो ऑब्जेक्ट कंटिन्यूअसली मूवमेंट में हो और अगर हम कोई फोर्स उस पे अप्लाई करते हैं तो इक्वल एंड अपोजिट फोर्स उस पे अप्लाई होता है, उसे हम अनबैलेंस फोर्स. सो दैट इज ऑल अबाउट द बैलेंस एंड अनबैलेंस फोर्स. सो द रिमेनिंग पोर्शंस वी विल लर्न इन द नेक्स्ट वीडियोस. थैंक यू.
Thank you for watching this video.